Thank you for your work.
Okay, yeah, well, welcome everyone to this talk about the ISDN and POTS network at Congress and Camp. Yeah, there's a slide about myself, which I'll skip. Anyone wants to read up on that can do that at some point. So to put this a bit into context, I think historically the CCC has had a very close relationship and has been entangled with data communications and telecommunications, right? If you look at the early CCC, it was the time of DFÜ, Datenfernübertragung in German, so that's wide area networking, but in German it sounds much cooler. You know, and there were acoustic couplers and even the Datenklo, the do-it-yourself acoustic coupler that was described in the CCC member magazine, as of course also the BTX hack, BTX being the German online system proposed by Deutsche Bundespost back in the day in the 1980s. And then of course there was a lot of exploration in the dial-up era of various creatures and hackers of all kinds of dialing into accessible and not so accessible, or officially or unofficially used Unix machines and BBSs and whatnot that were available there. And then also, of course, the DATEX-P network, the German X25 network, and later, of course, ISDN. So there has been a lot of traditional, how can I say, use and relationship between the hacker community in general and CCC in specific and telecommunications technology. Now, if you look at the telephony at CCC events, like very briefly and historically, the POC or also the event phone team have been running telephony at the events for more than 20 years, maybe 25 by now. I'm not the exact historical record keeper about that. And they started with a circuit switched private branch exchange from Alcatel with wired telephones and decked cordless phones. So this is traditional circuit switched time division multiplex PBX, so private branch exchange structure with circuit switch decked access points and primary rate ISDN as the uplink to the external world. There's a talk about this, it's linked in the slides, Event Phone früher, heute Morgen, from a couple of years ago, where the history of that particular event phone and POC team has been presented in detail. Now today, of course, today, sorry for the missing A there, the POC, the Phone Operation Center, has completely migrated to VoIP. There is still DECT, but even the DECT base stations are connected over IP. So there's not really anything left that relates to traditional circuit switch telephony in this setup, which is nice. I'm not criticizing that. I'm just saying technology has evolved, just like in the real world, in the public networks. Circuit switch telephone networks have been replaced by or superseded by voice over IP. The POC has meanwhile been complemented by GSM and now increasingly Welte networks by the C3 GSM team. So that's sort of the let's say, what people know and are used to at CCC events before the Camp 23 and 38C3 and 39C3 when we started this analog and ISDN network. So DECT and GSM and also VoIP, of course, is nice for voice, right? You can make phone calls and talk to people, but all the other legacy communication services usually don't work so well over modern technology. So dial-up modems over VoIP, you can do it with limited bitrate for a limited amount of time if you're lucky, but it's not really working well. ISDN data calls over VoIP, not really possible. Yes, there are some very specific, but not in general over a normal network. Same with telefax. Ever tried faxing over DECT? No, certainly not, or BTX or Minitel. So yeah, so if you want to operate or use any of those legacy services or many other legacy services, then the modern voice-centric technologies are not really useful. So that's where the C3 ISDN team comes into play. Where our idea is to operate a classic digital telephony network of the roughly 1980s to 2000 or maybe 2010 era, which means we provide classic analog and ISDN subscriber lines. Subscribers means users here at the event. And it's not about emulating the user interface, that's like operating some asterisk machine or something and emulating that, but operating the real telco equipment from that era at all levels of the stack. And reenactment basically, but not emulation. So I mean, in retro computing, there's always all kinds of people running emulators, people running the real thing, and so on. And we said, well, if we have the chance, and luckily we do have the chance with decommissioned equipment to really operate the real thing. It's sort of part of a wider mission of a group of people, a self-proclaimed mission to keep our digital heritage alive. I think that's something important. Many other people probably don't agree, but anyway. So who are we? There's a team, mostly Jolly, CRX, Xenti, Drajek, Grutzkopf, Wimpy, and myself. So of course, lots of helping hands of others working on this. We know each other from a community which we call retro networking. And yes, this is basically people enthusiastic about historical, mostly digital communications technology. So what do we have to run here at the event in the context to provide these services? So in the classic telephony network, what do we have? We have subscriber equipment. That's what everyone is familiar with. The phones, the modems, the fax machines, the ISDN terminal adapters, private branch exchanges, and so on. That's basically what people, at least of a certain age, have all experienced in their life, in the real world. That equipment connects to a subscriber line. The subscriber line is the copper wire that goes from the home or office or whatever to some equipment of the telephone provider. It is terminated in something called subscriber line termination equipment, and that may or may not coincide with the location of a telephone switch. Also, some people call it a central office or an exchange, which is basically what is connecting different subscribers based on numbers dialed and so on, and routing calls across the network. And then also in a real network, you have something that is typically even in a telecommunications operator run by a different team, is the transport network, which transports certain interfaces that are internal to the telephony network across longer distances. That transport network is then used for connecting telephone switches in one city with telephone switches in other cities, for example, or also to connect a telephone exchange with dislocated, like remote subscriber line termination equipment. We will talk about that in a sense. And that's sort of what we are building up here at the CCC events, as I said, Camp 23 and last year's Congress and this year's Congress, and hopefully also in future installments of CCC events. So this is the rough logical structure of the network that we're operating, symbolized. So we have at the central part of the network, we have something called the Siemens EWSD. That's the Elektronisches Wählsystem Digital. That is the type of switch, and I'll talk about all these elements a bit in more detail. Let's just skip that for a moment. So this is the actual exchange, and then we have remote subscriber line terminations, which are called V5AN here in this diagram. We have more than 8, it's actually 13 this year. They are distributed across the venue in different patch rooms or different rooms in the assembly areas and so on. These subscriber line termination equipments, and from there then we have individual subscribers using an analog line, which in German telecom language is an AB interface, or an ISDN basic rate subscriber is an ISDN basic rate interface. So that is the kind of interfaces we provide at these V5 access multiplexers. The ISDN primary rate subscribers, so if somebody brings a PBX or some server with a primary rate interface, those go, well, this is actually wrong, embarrassingly, the diagram. Well, no, it's, okay, we'll look at it in more detail. It's still connected to the EWSD, yes, of course, but it doesn't go through these V5 multiplexers, so those are just for basic rate and analog access. And then basically northbound of the Siemens exchange, we have a Portmaster 3, which is a RAS server for dial-up services. So this is what you use if you do PPP dial-up internet here at the event. We have a Yate-based fax and other service machine. This is where the fax polling services are located, for example. We have a machine called Noodle, which is the ISDN to SIP gateway, which then connects to the POC, to the phone operation center, which in turn connects to the C3 GSM and also to the public telephone network. So it's fully integrated with the other telephony teams here, and it's one numbering plan, and you can make and receive calls from the public network into the ISDN or analog network, into GSM, into voice over LTE, and so on. It's all interconnected. Okay, so the Siemens EWSD switch, elektronisches Wählsystem digital, is a digital telephone switch, as the name digital implies. It was used in more than 100 countries around the world. In Germany, it was the primary used system, so there was also Alcatel System 12, or originally SEL System 12. Which was then bought by Alcatel, but I think at least 2/3 of the exchanges in Germany, local exchanges, and also, well, I'm not sure what the English word is for the like higher level exchanges in the network. Well, yeah, and they're like in German PSTN, they're all switched off by now, virtually, because, well, there might be some small city carrier somewhere that still operates one, but like in general, they are all phased out by now. They were used in many other countries as well, and a couple of years ago, we were looking at this technology and we were trying to figure out whether there's any museum in the world that has an operational switch of this type, and we didn't find any worldwide, sadly. We have meanwhile rescued at least 5, it might be more, EWSDs, which are some in museums now, others in hackerspaces or in personal homes. So we keep that technology at least alive. We have not managed to do that with Alcatel S12 so far because we simply couldn't find any, well, primarily software. You can find some hardware, but finding the software for those switches is very hard. Okay, so a typical Siemens EWSD exchange in the smallest configuration that you could get from Siemens was 8 racks. Which is, well, a bit much for an event like here. So Jolly finally managed to boil it down into an operational minimal system that is not documented anywhere in the Siemens documentation, and you can basically squeeze it down into a single rack, where then you lose all the redundancy, the failover. You don't have any hard disk drives or tape drives anymore. You emulate those. And you don't have built-in subscriber line termination in that single rack, but we use these remote subscriber termination units, the access multiplexers I mentioned before. So how does this look like? Well, if you've seen it here, this is our EWSD exchange. The picture is actually taken yesterday here on the event. This is next to the POC help desk, left of the POC help desk and right of the Wikimedia assembly. Wikipedia, sorry. Yeah, this is, of course, the eyes on the doors are not original Siemens. They are aftermarket tuning parts. If you open the doors, it looks like this. Well, you will see some other face reflecting in the plexiglass in front of it. Also, the plexiglass is not original. We just added that to prevent ESD discharges by enthusiastic hackers touching equipment. There is an additional layer of safety in front of all the different boards that you can see. And if you look at it from the backside, it will look like this, with or without somebody debugging it comfortably on the ground of the CCH. Yeah, so that's sort of how it looks like, the central office or the exchange that we use. And now we need to somehow get from this location to other parts of the building and to the subscribers eventually. We use an SDH network for this. SDH is synchronous digital hierarchy. It's completely unrelated to the telephony service. It's really a transport for digital bit streams. And we use it, and also traditionally was often used to carry primary rate digital E1 carriers. We had 10 distributed add-drop multiplexers last year. This year we have a couple of less, I think, so far, but the exact quantity doesn't matter really. We also added some point-to-point stubs. So what is SDH? It's this bit synchronous technology. It uses fiber as transport, also dates sort of in the same time frame. 1988 to 1990 was the specification phase. You have different multiplex levels, meaning different bit rates. If you're from the US and you've never heard of this, you may have heard of SONET or SONET with OC carriers. That's the American well, sort of approach to this, similar but different rates, like many things in telecom. And the smallest level that we operate here is STM1 with 155 megabits, which means 63 E1 carriers, which means you can carry 1,890 concurrent voice calls over one such fiber in the setup. Of course, we don't get anywhere near that limit in our setup here. The reason why one built networks this way with digital synchronous bit rates and multiplexers as opposed to store and forward switches we know from Ethernet and packet switch networks is that memory was simply not available and extremely expensive back in the day. So if you just bit multiplex, you don't really need memory. You just need high-speed logic and transceivers, but you don't need memory to store, and you don't need complex CPU power to okay, yeah, so the SDH equipment that we use here primarily is Ericsson Marconi OMS 860. They're add-drop multiplexers, meaning that you can put them in a ring, and at every position where you have some multiplexer in the ring, you can add or drop E1 carriers from that ring, from the STM1 multiplex. It has 16 E1 interfaces on RJ45 tracks that you can see here, the block in the middle, and you have SFP slots for the optical transceivers. This is very late generation SDH equipment. We would want to use more legacy equipment, but sadly, the fibers in these buildings are all multi-mode, as you might have heard from the NOC and other people complaining about it. And even in the 80s, the telecom equipment already used single-mode fibers, but the modern fibers put in this building a few years ago during renovation are too old for our 1980s style legacy equipment. So we need to find modern SDH equipment that has SFP slots so we can put multi-mode transceivers in it so we can actually use the fibers in this building. Yeah, so the other multiplexer we use here is a RAD FCD 155. Difference is that it's a terminal multiplexer, so you can't build a ring from it. It's just a point-to-point connection. It has the E1 interfaces, sadly, on a high-density D-sub connector, so we had to build a small breakout board here to actually break those to RJ45, which is something we did a lot, like making small boards for adapters and so on. Okay, now we have a transport network, means we can bring sort of high-speed bitrate signals from the exchange to all across the building. And now we need to terminate subscriber lines, so we have subscriber line termination equipment. That is, in our case, we use something called V5 access multiplexers. This is also, again, late generation of digital telephone networks. Originally, the subscriber lines all went into the exchange, like all the way up to the EWSD. And then later on, in the 90s, late 90s particularly, remote subscriber line termination came phased in. So you didn't need an exchange in every village or every town, but you could basically remotely attach subscribers that way. So what we use is primarily the Nokia EKSOS N20, which has a capacity of up to 480 analog or 240 ISDN basic rate interfaces in a small rack mount unit originally. But since we don't have racks everywhere here in the assembly areas, and particularly not in the camp, we built these wooden self-contained carry boxes that contain the necessary breakout to RJ45 sockets here at the bottom and contain some fans and also a power supply. And so it's basically a self-contained box that also has handles. And in this stage of assembly, the handles were missing. But yeah, originally this was the first approach, and yeah, as you can see, lots of wires that need to be individually soldered, lots of manual labor, and this didn't scale. Nobody wanted to do 13 of those units, so we did a small breakout board and so on. So the idea is that from the multiplexer, as you can see, there's line cards next to each other here in the picture. And we just removed half of the line cards because we don't need the capacity. And instead of the line cards, we put these breakout boards next to the line cards. So we have the individual. Yeah. Okay, so we have RJ45 breakout boards. This is one that's deployed here in the next to the YOLO Colo here at the event. So you can see basically we have the Nokia line cards and a ribbon cable connector next to it, the breakout card. So this is our aftermarket usability improvement. So we don't need to solder all those wires or wire wrap them or something like that and have a more convenient way. You can also see at the bottom actually one of the SDH multiplexers beneath it. So the fibers you can see left and right, this is our SDH ring that goes to the EWSD. And here the RJ45 connectors are the individual E1 lines, and one of them goes up here to the left-hand side where we have another breakout board to go into the multiplexer, and then subscribers can connect to those slots over here. Okay, what kind of services do we have? We have analog voice telephony, we have modem and ISDN dial-up. We have a variety of BBSs that can be reached, including a CCC event BBS called C3 BBS. You dial-up, always modem or ISDN, both is possible. We also have internet dial-up, analog, sadly, not below 2400 BPS. That means no BTX termination and no Minitel termination. That needs to be done differently. ISDN at 64K, and of course you can do channel bundling for higher bit rates. By the way, thanks to the NOC, we have an entire /23 of public IPv4 space. So if you do analog modem dial-up for internet access, you actually get a real IPv4 address, just like back in the day. Of course, there's so much background flooding and traffic that we do inbound filtering, so there's connection tracking with stateful packet filtering in between, so no inbound connections, sadly, but otherwise your modem line would be just busy with all the background port scans and whatever is happening here. Yeah, there is Chaos Post, again a typo, sorry for that. So there's Chaos Post Gateway as a dial-up service, so you can dial into that and you can write a postcard from your terminal. There is ISDN video telephony. Video streaming of lectures would be nice, but sadly there is no open source software that can interface with the ISDN video telephony, so a lot of code would need to be written. It's on my to-do list, but there are many other things on the to-do list. We also have a lot of fax services, the various fax machines distributed. Also, everyone can, of course, bring their own fax machine or fax modem. We also have a public fax machine. We have a fax to Fediverse gateway, so anyone can send a fax and it will get posted to the Fediverse. We have fax polling services, some funny, some useful, so you can get the phone book basically as a fax polling service. And the service infrastructure runs on this equipment. Looks very professional, right? So we have in the middle, we have a Livingston Portmaster 3. There will be a slide about it. At the bottom, we have a Cisco AS5400, and here we have a small N100 NUC style, but different manufacturer device with an open source ICE1 USB. That's a USB primary rate interface. Connected for the fax services. So we have this N100 mini PC. It runs Yate, has the fax polling services and the fax to Fediverse gateway, which is custom development, of course. We have the Livingston Portmaster 3, which is this dial-up service with 2 E1 lines, so it can have up to 60 concurrent modem and or ISDN dial-up calls. And the way we do the BBS access is that the BBSs don't have to each have their own modem, but we can also make remote BBSs somewhere else on the planet available because the portmaster can basically terminate a call, and based on the dial number that you have dialed, it queries the radio server, and the radio server returns the telnet IP address and port to which it should basically forward the connection. So you can make an analog dial-up connection into a BBS that's located in the US. Still here it's fully analog, and it's going through of course, through the digital network, but at least it's a normal dial-up call. As an experiment, we also brought the Cisco AS5400, so if we ever need more capacity, this one can terminate 480 modem calls in parallel and do all the modem DSP stuff, so if people bring more modems, we are prepared. How to join the network? Well, you need to find the nearest point of presence. That's these V5 access network boxes, these wooden boxes that are in the field. Sadly, up to right now, the C3 ISDN layer in C3 NAV is still outdated. They copied the data from last year, but we still haven't the credentials to actually update the locations for this year. You need to run the telephone wire to that. Please do that safely within cable bridges or wherever. If you need patches through the building infrastructure, we can help with that. To bring the ports you need as close as possible to your location. And you can just connect to any of the ports on the leftmost ISDN or analog line cards. Look at this again. So that would be this one here. Is an it's an ISDN line card. How can you see that? Well, it's labeled ISDN at the bottom, haha. And there's an analog line card, which is here, and the leftmost of those also is pre-configured. So you can plug into any of those ports, and you automatically have a number that's fixed, basically routed fixed to that port. We don't do, vanity numbers or any of that. That would be too much work. So yeah. That's how you join. If you need an NTBA, the network termination, we have a box full of those. If you need anything else, like a specific cable or adapter, we brought lots of those. Yeah, and if you don't have if you didn't bring any of your own equipment, there are some fax machines. We're also setting up ISDN video phones, and also some analog phones are around the EWSD exchange that you can just pick up and make and/or receive calls. Yeah, if you want to provide services, you can connect, of course, your own servers, right? If you have a modem and a machine that's running, a server could also be a Raspberry or whatever you want. You connect it to a phone line, and people can dial into your box with that modem or ISDN adapter. If you brought more enterprise-grade equipment with primary rate interfaces, as said, we can also provide those, so you can terminate more calls. If you just want to operate a BBS, expose it on some internet-facing telnet port, and we can configure the port master to have a phone number routed to that telnet. Yeah, so you can also hack up your own service for YATE, and we can add that to our YATE. It's also an option. If it's a voice service, you can also, of course, just attach that to SIP and then call that from the ISDN or analog network. If any of you wants to help us, well, we usually have a lot of work during Bring Up. This year we started on December 20. With the SDH ring deployment and access multiplexer deployment, so you can see there's a lot of infrastructure work. Also during teardown, we are always happy to receive help. Also, if somebody wants to help us with answering frequently asked user questions, like how can I connect to the networks, like RTFM, helping connecting subscribers and so on. So if any of you has fun or wants to have fun with that technology, let us know. And also, last but not least, make use of the network, of course. There's a couple of links for further information. If you want to reach us in chat or over the Fediverse, check out the addresses given there. And that's it. That's the end of file. Thank you so much.
Thank you so much for your very informative talk. As it seems that the microphones are working again, please, there are many microphones from which you can ask more questions to our speaker. Someone is moving. Please, number one.
Yes, the nice thing about the old POTS service is that you do not need a local power source to connect your phone. Does your system also provide power to analog phones and ring signals, and how much power can I get from your system?
So yes, it's a real subscriber line termination. All the equipment we used was part of the public telephone network in Germany. So it's real, and there's phantom power supply. How much power you can get, I don't know. It's whatever was specified or used. The ISDN lines we have configured to 65 volts output voltage. Because it's the lowest voltage we can provide. It can do up to 96 volts, which is a bit, yeah. You don't want to touch that. Of course, it's current limited, yeah, so there's real ring voltage. You can take a 1920s phone with an electromechanical ringer and you can connect it. This is not PBX technology, it's the real public network, yeah.
Thank you. Number two, please.
Yeah, you mentioned that you were able to save some of these EWSDs. Do you have any interesting stories about where those came from? Because I've been involved with some stuff in the US for various switches, and I'm just curious because a lot of times there's good stories.
Yeah, there are some donors who want to remain anonymous, but there is one, for example, from British Telecom Deutschland. There's no NDA about that. We just disassembled two EWSDs in October in Munich from a location that they had to move out. Those two have gone to the called Fernmeldemuseum Dresden, so the Telecommunications Museum in Dresden, which is a non-profit that operates, I think, 11 or 12 exchanges from various generations in Dresden. And they will also add EWSD now to their collection. The others, well, I can say they are mostly from smaller private city carriers, I would say. It's not like Deutsche Telekom or Vodafone. Yeah. In those cases. And the most difficult part is, as I hinted with the S12, is the software. Because what happens is that most standard operation procedures is when the equipment gets shut down, remove all disks and destroy them for privacy and data protection reasons, because there are call data records and stuff on them. So even if the equipment is still there 10, 15, whatever years after it being switched off, the disks are gone. And without the software, what can you do with the equipment? So luckily, we have managed to get some units with software. So I think there's like three different software releases or so that we have now, and that we can operate on those switches.
Yeah, that's been a similar thing in the US. It's like, okay, well, we can get one that's from somebody's test lab, and then that's the best thing because it's got all this stuff, and it's like, yeah. Cool.
Okay.
So I see there is a question from the cyberspace.
So the internet is asking if the used software is archived on archive.org.
No, the EWSD software is not archived on archive.org, and we specifically did not do that because it's EWSD is still used in production somewhere, and it's of course a lot of very expensive licensed software from Siemens. So we did not upload that on archive.org due to the copyright situation and also the provenance of that software. So no, that is not the case. But also, I mean, without the EWSD hardware, there is no way to make use of that software, right? I mean, an EWSD exchange has like hundreds of processors of different instruction sets. Each line card has different CPU architecture and different, it's like each different module. You have hundreds of different modules and they all have different architectures. It's like a complete universe of itself.
So if you want to ask more questions from the cyberspace, you can go to hackint.org, hashtag 39C3-hall-0, or join the metrics space for 39C3 and join the room hall 0. And now another question from microphone 1, please.
Hi, is it possible to send a fax through the public dial-in of the event phone to an ISDN connected fax machine?
It was reported working many times last year. This year we've received 2 reports it's not working. I don't really understand why. We certainly didn't change anything on our side. There might be something related to the SIP uplink of event phone. We haven't really found time to investigate why that is, or we haven't even verified those reports. But if anyone wants to test, just try it and see what happens. I mean, you can, for example, just send a public, like from a public telephone network, you can send a fax to the fax to Fediverse gateway here and see if it shows up on the Fediverse. So that everybody can do that and test that and see and get immediate feedback.
All right, another question for microphone 1, please.
Thanks for the great talk. I'm coming back about your work of the video, ISDN video feature. Is there already some work done, or is it just some idea on a big list?
There has been a lot of work in investigating the specs and also writing a bit of code regarding the outer multiplex layer. So there is in the I forgot what it was it H.100 something. So there is basically, I gave a talk about this. It's on Media CCCD. I gave a talk about how ISDN video telephony works on a technical level. I forgot most of it by now. It's like 2 years ago or 3. And there's a bit of code basically to sort of, and we took protocol traces of the B channel between 2 ISDN phones, and we can sort of decode the outermost layer with that. And the actual video codec, luckily, at least theoretically, I think it's part of FFmpeg or VLC. Basically, it's available. It's just basically all the multiplex around it, which is crazy. I mean, it's very fun, but look at the talk. So you have a 64 kilobit channel. So basically 8 bits at 8 kilohertz sample rate, and every byte you divide into separate subchannels. So you basically have 1 bit per byte as a subchannel. So you have 8 subchannels, and you have framing in there and multi-framing inside. It's a fascinating technology. Okay.
All right, there is a final question from the cyberspace.
Yeah, someone on the internet has read that SDH is a synchronous interface. Do you know how it distributes the clock signal? And are phase shifts due to wire length an issue?
So the SDH network transports clock alongside the data. So basically, you have one master unit that has the reference clock. In our case, we take that from the EWSD because the EWSD sort of, we don't have a network where we have 10 different exchanges. Normally, you would have like a clock distribution network and an atomic clock and so on, like in a real public network. But here we sort of say the local oscillator of the EWSD is the reference clock, and that we feed into the SDH as clock master into the first multiplexer, and then it distributes along the ring. So basically, every unit that receives the signal derives the bit clock from the signal it receives and uses that as its own clock for transmit again. And for the size of the network that we operate here, that's perfectly fine. There's no issue with phase shifts or something like that, because it's recovering the clock from the received signal.
All right, then, thank you all for your questions, and let's thank again our speaker for this very interesting talk.